In this video, we're going to look at soil temperature and how this affects activity in the soil. In the UK at the moment, we're kind of in the depths of winter and things have taken a real cold turn. So I thought it'd be quite a nice time to have a brief look at how this affects things in your soil. Now in the UK, we are well and truly in the middle of winter. It's been quite a mild winter so far, actually, particularly where I live, which is in the south of the UK. In other parts, they will have had snow. It will be significantly colder. But the last few days or so, it has really taken a turn. We've had a couple of really hard frosts. And I always kind of think when I look about the garden, when I look outside, how much this kind of seems to mess around with some of the natural processes. And I'll show you what I mean. So what I mean by that is we have little buds from my peonies breaking through the soil, and we have had some hard frosts this week already. We can see under the acers here and amongst the mulch that we have some bulbs also breaking through, as well as a dog. The grass weeds around this olive tree. Oh, and I didn't notice this pot is actually cracking. The little grass shoots are already emerging as well. And under this bush there are some more bulbs breaking through, and I'd kind of expect that here because it's a little bit more protected. So I'd kind of expect perhaps in the more protected areas there to be the odd plant emerging, but maybe less so in the more exposed area. And yeah, we've had a couple of hard frosts. We're probably going to get some snow later this month. And what this tells me is that things in the soil are active. Things are growing, therefore the soil underneath it is active as well. But this will change throughout the year. And I thought it'd be quite good to have a look at a little piece of work we've been doing where in the laboratory we've been collecting soil from the same location every month for the last 4 years. And this has enabled us to track biological activity in the soil. So I'm going to put up a graph on the screen and we can look on a month by month basis how the soil activity levels change. Now, first thing to note here is that I've added up the biomass of bacteria and fungi. So I'm going to call this total biomass. And I'm also going to show you the total active biomass as well. So that's all of the bacterial mass, all of those organisms, and all of the fungal mass. We're going to add up into one figure called the biomass and show that on a month by month basis, how the total changes, and more importantly for what we're looking at today, how the activity changes. So before we start, we'll just quickly look at the moisture in the soil. Now, if you're unaware of the importance of moisture in soil, I'll put a link in the description below to one of the other videos I've done on this. This is incredibly important as a main driver for biological activity. And so we've got these two lines here. The blue line represents the moisture that the soil holds. The orange is a hard value. It's in millimeters. It's the amount of rainfall. And this is an average over the course of a number of years for the area in which these samples were taken. The data set was actually bigger for the average rainfall than the moisture, so there will be some discrepancies. And actually I would say that the last 4 years, which is the time frame from which we've collected this data, the weather patterns have been a little bit odd, but interesting really. I suppose nothing too out of the ordinary, but interesting just to see the relationship between rainfall and soil moisture percentage. The two are obviously very closely linked, and what this generally shows is that kind of from autumn through the winter through to mid to late spring, soil moisture is at its highest. But I said that we would be mainly concerned with the organisms in the soil, the biomass, so that's the total amount of bacteria, total amount of fungi, added up to create one value, which is in micrograms per gram of soil. The orange line here represents the total average biomass, so the total amount of bacteria and fungi that is either active or inactive in the soil. We can see that this peaks at around May, and then it kind of goes up later in the year, sort of September, October onwards. It starts to increase, and then it reduces through the winter time, which obviously we're in now, and it kind of reaches a low around February, March. And the blue line, which represents the activity, sort of tracks closely alongside this. I've put the average active biomass onto a secondary axis because there is, in this particular soil, it's quite a small fraction of the total biomass that's actually working at any one time. So interesting again to see the relationship. Again, I've talked about this in the past, kind of seasonal variations and what we expect in the soil. Things tend to kind of hot up, actively speaking, towards the later end of the year, sort of coming out of harvest, summer harvest time into the autumn. Things go up and then they start to reduce from winter onwards. And obviously activities generally at its lowest in the summertime when temperatures are at their highest, and also soil moisture is lower as well. But the title of this video was to look at temperature in relation to soil activity, and this is it. Now, again, this temperature is taken from a very large data set over a long period of time, and it relates to the air temperature. It's taken from a Met Office station. So it's kind of historic. It's not necessarily fully representative of the last 4 years over which the active biomass data, the blue line, is taken from. But what it does show is that when temperatures are at their highest in the air, the activity in the soil is at its lowest. And again, this is generally speaking around the summertime, sort of July, August time in the UK. I suppose that the amount of activity, the degree to which it actually drops, will depend very much on a whole host of factors, not least the soil type you're dealing with and its ability to conduct or transfer air temperature through to the soil. And this is why when you get to the colder periods of the year, it kind of takes 2, 3, maybe 4, even 5 kind of hard frosts for the soil to cool sufficiently to make all of the organism activity in the soil reduced or kind of make certain organisms dormant. So yeah, key takeaway from this really is when temperatures are at their highest in the air, the soil temperatures will be at their highest and the microbial activity will be at its lowest. So just by way of closing, it's always good to reflect on the moisture content of soil in relation to organism activity, because this is one of the most important factors. Now, obviously, the temperature, the amount of rainfall will have a significant role in determining what the soil moisture content is, as will other factors such as soil type and amount of organic matter. But it just so happens that on the data that we've collected over the last 4 years, the soil moisture content is at its lowest when the air temperature is at its highest. And so it follows that organism activity is at its lowest when temperatures are at their highest and soil moisture content is at its lowest. So there we go, that wraps this video up. I hope you found it useful and interesting. If you did, please give it a like, that really does help me. If you like videos that show you stuff about soil, focused on helping you to grow better, tastier, healthier plants and crops for you and your family, then do consider subscribing to the video. For now, that's it though. I look forward to seeing you in the next video.